So here we have A, B, C, D is a quadrilateral, and P and Q are the midpoint. Mark this word. Midpoints of AD and DC respectively. Show that PQ is equal to AP plus QC. Now, from here, ABCD is a quadrilateral. Quadrilaterals are four-sided shape. We draw any four-sided shape of our choice. Any one. I can go with rectangle. I can go with square. I can even go with parallelogram if I want. But let me go with rectangle. Now, let me give them name. Now, another thing you have to be careful on naming them, naming those edges, is either you name clockwise or you name them anti-clockwise. Do not name like this. A become here B, C, D. No. It's only in triangle that you can go anyhow and it will still do what? Rhyme. But under quadrilaterals, it's either you go clockwise or you go anti-clockwise. Now we have here, from the question, they said that P and Q are the midpoints of AD and DC respectively. This is our AD. Here is the midpoint. We put P. Here is the midpoint. We put what? Q. Here is the midpoint. We put our what? Q. Now, remember they said AD. It means that A is going to D. You understand? Which means they are still going like this. There is no other law. We can join P and Q what? Together. Now, we said PQ here, which means P is going to what? Q. They mentioned DC here. We have this. And DC, they also mentioned QC. So it's going like this also. Is there any other one? AP. So it's going like this. So we have defined everything we need to know on this one now. Now, how can we show this? How can we show this? From the triangular law of vector addition, because we can see triangle here. We can see triangle here. From here, from this place, we know that PD plus DQ is equals to PQ. You can see PD plus DQ is equals to PQ. We stop. We can see PQ is here, is equals to something. PQ in our proof is also equal to something. But we have AP here, we have QC. Here we have PD and DQ. How can we solve them? Now go back to the question. I marked this midpoint. For something to be a midpoint, it means it is at the middle. It is at the middle. That from here to here is the same thing as here to here. So we can state that AP is equals to PD. Since P is the midpoint of what? AD. Also, we can say, since P is the midpoint of, since P is the midpoint of AD. Since P is the midpoint of AD, so AP is equal to what? P what? PD. Another one, DQ is equals to QC. Since Q is the mid, since Q is the midpoint of DC, you can see. Now, if AP is equals to PD and DQ is equals to QC from here, we can now say that if this is this, we can represent this with this. We now have AP here. Since this QD is equal to this, we can use this to represent this. We have plus QC, which will now give us PQ. Proved. We are done with our proof. We have already shown that PQ is equals to AP plus what? QC. And that is end for this. In this example, we have if the vectors A, B are represented by the sides AB, AC of a triangle ABC, what vectors are represented by BC, CB, and AD, where D is the midpoint of BC? In this question, from here, we know it's a triangle. We draw any triangle of our choice. Any triangle of our choice. Let's draw it one side because we have many things to calculate. We have a triangle. We have a triangle. On this triangle, we now name them. Let's name here A. We have B here. We have C. That is A, B, C. We are trying to answer number 1 now. But we have not done with the fixing. From there, remember they mentioned AB and AC is represented by a small letter A and small letter B. AB, that is moving from A to B, we have A. And AC, moving from A to C, we have what? Vector B. Another one they mentioned from here now, since we are answering number 1, they mentioned BC. So for BC, is moving from B to what? C. We go this way. And this one. But remember, we are looking for what? BC. We are looking for BC. So number 1, you can see, if we start from AB, from the law of from the triangular law of vector addition, you can see if we start from AB, it can go to BC, then is equals to AC. We state it, AB plus BC is equals to AC. Remember, we are looking for BC. And we have something to represent AB and AC. So we have that A plus BC is equals to B. We make BC the subject of the formula. We have now that BC is equals to B minus what? A. That is our what? BC. The second one, we are asked to find CB. We are asked to find CB. From our vector, episode 1, negative vectors. Negative vector. You can see that this is in negative side of what? Of this, under the same diagram. So, we can now say that CB is equals to negative of BC from the law of negative vectors. This is equals to negative of this because they are not moving in the same direction. This one is moving from B to C. This one is moving from C to what? B, under the same triangle. So this one is moving like this. Instead of us to calculate it like this, we can still follow here up and get our answer. If CB is equals to minus this, we can now say that CB is equals to minus open bracket vector B minus vector A. We now say that CB is equals to minus B plus A. Can now say that vector CB is vector A minus vector B. And we are done. We have already shown how we get this and how we get this. Now moving to I say we should find AD. Now they give a statement where D is the midpoint of BC. D is the midpoint of BC. This midpoint is very important. A midpoint. Now look at this midpoint here. We have a midpoint. Now let's join it from A. Let's give it a broken line because it's not in our initial diagram. And we should find D is the midpoint. We call it D. And they said we should find AD, which means the vector is coming from what? A. We have a vector coming down from A. Then, remember this one is moving like this. It's also equal moving like this because there is no law here that says that it's moving this way. So BC is still moving this way, and D is the midpoint. Now, we continue. If you watch closely inside this triangle, you can find that we have two triangles now. We have one right angle this way, and we have another one right angle this way. And we are asked to find AD. And AD is the height of the two triangles. So we have to consider this and also consider this one. Let's start from this place. From this triangle, you can see we have AB moving like this. It can go like this. We have plus AD going like this, which will now give us, from here we have AB going like this plus BD, which will now give us AD. Now, from here, our AD is already the subject of the formula. Let's say we don't have any problem here. We continue another one, although we can still represent it with A or what? B, if we like. Well, let's leave it like this. From here, we have that, let's call this one I. From here, we have that AD comes down plus DC, always remember to put this, plus DC will give us AC. AD plus BC will give us AC. From this one now, we can now make our AD the subject of the what? Formula. From here, we now have AD to be equals to AC minus DC. We can now call this one equation 2. Remember, we are looking for AD. From here, we add them together. Let's arrange them out. We have AD is equals to AB plus BD. That is from equation 1. From equation 2, we have AD is equals to AC minus DC. We add them together. We add them together because we are looking for AD. So we add them to have AD. If we add them together, we have here to be what? 2AD equals to, if you add this, we have AB plus AC. Coming to this place, BD and DC. Come over here. We have BD and DC. And remember that D is the midpoint that divides the two. If here now is F and here is F also, if we have plus F minus F, it will give us 0. So BD minus DC will give us 0. Will give us 0. So since it gives us 0, we leave it. We continue with this one. We have that 2AD is equal to, what is our AB? We have small letter A plus small letter B. So our AD now is equals to 1 all over 2, open bracket, A plus what? B. And this is the end of this question. Thank you.